Okay, everybody, we are now beginning the crucial sample problems that you will see for the state test. That's going to be really important for you guys to get these down. And then you're going to see these exact same ones. So you're going to see a number one just like this one in the future, but it's just going to have different numbers on it. And the same thing with number two, three, four, all the way through this entire um, set of problems. Okay, and there's going to be, let's see, there's 40 problems that are going to be reviewed. So this is part one of that. So here we go. Frank is riding a bike, or Frank is riding in a bike race that goes through a valley and a nearby mountain range. The table gives the altitude in feet above sea level for the 5 checkpoints in the race. Okay, so basically what it comes down to is if you think about it this way, um, if you have a starting point here, and then you're going to go up, you're going to probably be at about 647 feet there, but then it's going to go up quite a ways up to 2,540. Then it's going to go all the way down and then past, I guess, where sea level is and go down to a negative 191 and then all the way back up again, way past where you were before, 2,540 to 3,148, and then down to below sea level again to negative 44, and that's kind of where the race ends. Okay, so it's not going to look exactly like that. So, but we're just going to kind of like say, I don't know, about here would be sea level. Okay, and so you're going to see that it's going to go up over a hill and then down into a valley and up over a hill and then down into a valley. So that's kind of how the race is. So it's going to be a pretty intense race going up and down like that. All right, so what we're going to do is utilize that information to see if we can answer these questions. It says compare the altitudes of checkpoint 1 and checkpoint 4 using the greater than or less than, greater than or equal to. So less than, greater than or equal to. All right. So obviously, if you're here at 647, okay, and you're going to go to 3,148, okay, obviously 600 and something would be here, the 3,000 would be up here. So even though you go up, then back down again, then up, in comparison to these two, okay, it's definitely much higher. 3,148 is greater than 647. Okay, so moving on, it says, what is the meaning of the inequality above? Checkpoint 1 is higher than checkpoint 4. Well, that's not true. Or checkpoint 1 is lower than checkpoint 4. So that would obviously be the one that you're going to color in. Okay, let's look at the next one. Let's see if I can change a different color here real quick. So it says compare the altitudes of checkpoint 3 and 5. So we have 3 here. Okay, so checkpoint 3, when we did this little graph, was kind of down here. That's checkpoint 3. And then checkpoint 5 was here. So even though they're both negative, okay, between checkpoint 3 and checkpoint 5, okay, 3 would be lower than 5. So which one is lower, a negative 191 or a negative 44? Okay, so yeah, so the negative 191 would be further to the left on the number line. So that's going to be a lower number than negative 44. So what is the meaning of the inequality above? Checkpoint 3 is higher. Checkpoint 3 is higher than checkpoint 5. Is that true? Or is, and it says checkpoint 3, which is this one again, is lower than checkpoint 5. Okay, so again, that one has to be the answer to this one. Checkpoint 3 is lower than checkpoint 5. All right. So that is the first one, and I'm going to recommend that if you have the packet to go ahead and draw this out so you have this image for referencing for the future. Okay, and you guys can kind of utilize that for the next time you see a problem just like this one. Okay, for number two, it says find the distance between the points, and then here's your coordinate planes, -3 and 7, and -3 and 4. So find the distance between those two. All right, so to kind of understand this one, when you're plotting, you're going to go along the x-axis first with -3. You're going to go over to the left 3 and then up 7. And then um, for the second one, you're going to go to the left -3 and then up 4. So really you only have to find the distance between 4 and 7 because you're going to go over to -3 in both cases. Okay, so we're going to go ahead and go to another screen to kind of demonstrate that. Okay, so you always start right here in the middle of the coordinate plane, and that is called the origin. Okay, that's where you originate, or that's your starting point. Just like wherever you were born, that is the origin of your life. That is where you started life. So that's your beginning point, and you kind of go in different directions from there. So same thing with this. So we're going to do the -3, 7 first. So -3, always go along the x-axis first. Okay, so you're going to go -3. So starting at the origin, you're going to go -1, 2, 3. If it was +3, we would have went to the right, but it's -3. And then we got to go up 7 because that's a +7. 1, 2, 3, 4, 5, 6, 7. Okay, so that's going to be this one. Okay, -3, 7. All right, so I'm going to change the colors real quick. And on this one, we have -3 and a 4. So once again, we're going to start right here at the origin, at the beginning of it, and then you're going to go -3. Once again, that's going to be to the left. And as we see, going up and down, we are on the same line. So at that point, you could just see what is the difference between 7 and 4, and that's how far apart they are. But let's go ahead and plot it. So we went over 3, and we're going to go up 4. 1, 2, 3, 4. So there we go. So that is this one. And what they're asking simply is how far is it between these two locations? Well, it's from 4 to 5, 5 to 6, 6 to 7. So that distance is 3. So that would be our answer for number 2. All right, so coming back to the actual problem, we can see the distance between -3, 7 and -3, 4 is the number 3. Okay, so number 3, it says find the area of this parallelogram. Be sure to include the correct unit in your answer. Okay, so we've talked about this quite a bit. Basically with this one here, okay, we have to make sure that the base and the height are 90 degrees from each other. So basically the base of this is across here, okay, which is 14 centimeters. 14 centimeters. And then remember to find the height, the height always have to be straight up and down or a 90 degree from the base. So between 9 and 7, which one are we going to use and which one is just a wasted number that we don't need? Well, the 9 is no good. It's not coming straight up at a 90 degrees from the base. But the 7 is. Okay, so what we're going to use is the 7. So the two things that we're going to multiply together to get the area of this parallelogram is 14 times 7. And 14 times 7 is 98. And it tells us to include the correct unit. Well, it's going to be centimeters. And when we're finding area, it's not just centimeters, and it's not centimeters cubed. It is centimeters squared. Anything time you find the area, it is centimeters squared. Okay, so hopefully you jot all those notes down and extra ones if you need it, okay, to kind of help you again for the future problems. Okay, problem number 4, I kind of pre-worked some of the stuff. It says find the volume of the rectangular prism. Write your answer in simplest form. Okay, so I did put the formula up here. Volume equals length times width. So here's the length, here's the width, and here's the height. So you're going to multiply those three things together. Well, when you multiply fractions, it's actually the easiest thing to do with fractions because you don't have to flip anything, you don't have to find common denominators. And one thing that I kind of have shown over the school year is that you can cross reduce. Okay, so if you look at any of these problems, any of these fractions, if there's something in the numerator and the denominator that we can reduce, so if we look at the 5 in the numerator and the 5 in the denominator, we could say, you know what, 5 goes into 5, and later on, if we don't reduce it now, we're going to have to simplify it later. So if there's something in the top and the bottom that we can reduce, we can simplify it and make our life easier as far as doing the math, and we don't have to simplify later. So 5 goes into 5 once, and then 5 goes into 5 once. So now we've saved us some simplification later. But I mean, we can look at the 9 and the 1, and the 9 and the 4, and none of those can be simplified, right? So that's the best we can do. But that makes it really easy because now we're just left with 1 times 1, which is 1, times 4. So the numerator is very easy to find, which is just 4. And then the denominator is going to be 9 times 1, which is just 9. 9 times 7 is 63. Okay, so instead of finding the big number and then trying to simplify it later, that gives us our fraction, and we can't simplify it any more than that. And this time, instead of centimeters squared, it's going to be centimeters cubed because we are finding the volume. And volume is basically how many little three-dimensional cubes can you fit, okay, into the container that you're talking about. So we can fit 4 and 63 centimeter cubes into that box there. So that is the volume of it that will fit into this little container. All right, number 5. Aldo reads 42 chapters of a book in 6 hours. What is his rate in chapters per hour? So we need to get down to 1 hour. Well, to do that, we have 6 hours. We're going to divide by 6 to get down to 1. And whatever we do to one side, we do it to the other side. So 42 divided by 6 is a 7. So basically, out of the 42 chapters in 6 hours, they're going to read 7 chapters per hour. So that's all you have to do for that one. Just always get it down to the unit rate. Whatever you see per, that has to be down to the number 1. So it's per hour down to 1 hour. Okay, so for the next one, it's just telling us to divide 48 divided by 12. And actually, I like to change everything as much as possible into fractions because ratios, rates, and proportions are the big thing for this year, and that kind of extends into 7th, 8th, and even freshman math. So 48 divided by 12 could be 48 inside of a box and then 12 outside of the box. Or you can write it this way, 48 divided by, because that's what the line there is, divided by 12. So how many 12s can you get out of, or can you divide into 48? And of course, the answer is simply 4. So 48 divided by 12 is 4, and that's really all you have to do for this one.